I don't know. We'll find out right now. All right. So we've been waiting all this time for the derivative. We've actually been calculating it. As you can see, this is what we did in the last unit where we were calculating the tangent slope. That is called a derivative. So it says here, the derivative of the function f with respect to the variable x is a function f prime whose value at x is, and this right here is derivative. Cool, right? So you guys have been calculating derivative all this time. So that's all we're going to do. We're just going to calculate derivatives until we are sick and tired of them. Blah! Okay, don't worry. That's not, I wasn't actually going to puke, guys. So here we go. We got the, you can read that whenever you get a chance. I'm a little stuffy. So I sound the way I do, but that's fine. All right. Example 1. Differentiate, that is, find the derivative of f of x equals 3x squared. Once you find the derivative, find f prime of 1, f prime of 2, f prime of 3. You guys ready? All right, here we go. Let's go slow. I want to find the derivative of 3x squared, so I am going to do f prime of x is equal to, and all I'm doing is this right here. Limit as h approaches 0 of f of x plus h minus f of x all over h, which equals limit as h approaches 0, 3 parenthesis x plus h close it squared minus 3x squared all over h. Have I confused anyone? I'm going to go ahead and expand it. F prime of x is equal to limit as h approaches 0. 3 parenthesis x times x is x squared plus x times h is xh, but I have how many of them? 2. And then h times h is h squared minus 3x squared all over h. Now I'm finally going to distribute these. Maybe I should have done that before I put it in, but that's fine. Limit, I still haven't evaluated it, guys, so continue with the word limit. So here we go. 3x squared plus 6xh plus 3h squared minus 3x squared all over h. We're so far pretty good. Nothing crazy. What's going to zero out? It's always going to zero out like that. Now, what can I factor out? An h. So we're going to factor out the h, and I'm going to be left with 6x plus 3h all over h. What's going to cancel out now? The h's. And what is h approaching? So all I have is 6x. So I'm going to write here on the side, I'm going to write f prime of x. The derivative is just 6x. Hopefully you haven't seen Khan Academy or seen one of those shortcuts, because then it's going to mess up the fun. But there it is. There's my derivative, and they want my derivative at those three x coordinates. So here we go. F prime of 1 is just 6 times 1, which is 6. F prime of 2 is just 6 times 2, which is 12. F prime of 3, which is 6 times 3, is 18. And that's it. That's it, guys. How does it feel to take your first derivative? Yeah. You're ready for the AP exam. No, we need to do more, but. All right. You guys ready? This is an alternate definition. Both of them come out just as much. Don't freak out. F of x minus f of a over x minus a. You're still literally doing change in y over change in x, but this time x is approaching a. So this really is the same thing as saying h is approaching 0. It's the same. Ready, guys? It says, find the derivative of example 1 again, this time using the alternate definition. So it's finding it at a point. It's the only difference. Here we go. I'm going to write f prime of 1 equals, and I'm using this definition, limit as x approaches 1. What was the function? I already forgot it. Was it x squared? 3x squared. So you write 3x squared minus, and then f of a, so that's going to be 3 times 1. I'll write it over here. 3 times 1 squared over x minus 1. Now what, Chav? Well, I don't know. Let's keep going. Limit as x approaches 1, 3x squared minus 3 over x minus 1. What can I factor out in the numerator? A 3? So, well, yeah, a 3 and then difference of squares, yeah. Limit as x approaches 1, here's my 3 factored out, x squared minus 1 over x minus 1. And just like Abdul Karim told me, that's the difference of squared. Limit as x approaches 1, 3 x plus 1, x minus 1 over x minus 1. Notice the x minus 1's cancel out. And now I can just do direct substitution. What's 1 plus 1? And 2 times 3? Oh. 3 times 2? How did it change colors? I don't even remember changing the color to green. 6. Isn't that the same thing I got for f prime of 1? Yeah. I don't know if I have enough space there to do f prime of 2 and f prime of 3. So maybe we'll just do one of them.
So for f prime of 2, it'd be x approaches 2.
Yep. Let's do one. Which one? Do you want to do f prime of 2 or f prime of 3? 3. F prime of 3 equals limit. I'm using this alternate form as x approaches 3 of 3x squared minus 3 times 3 squared over x minus 3. Limit as x approaches 3. So I have 3x squared minus 3 squared is 9. 9 times 3 is 27. Excuse me. X minus 3. You can already see what's going to happen. I'm going to go ahead and write it in one step. Limit as x approaches 3. Factor out to 3. And it's going to be difference of squares because it's going to be x squared minus 9. So it's going to be x plus 3, x minus 3 over x minus 3. What's going to cancel? And then I plug in a 3. 3 plus 3 is 6. And 6 times 3 is? And there it is. F prime of 3 is 18, which is the same thing we got a little while ago. Is that cool or what? It's super cool. Is that cool, Lopez?
Yeah.
But you didn't see what we did earlier, Lopez. You're good, miss. All right. YouTube, let it be known that I do not bully my kids. So the notation. This is the most common notation, guys. This is y prime. dy dx, it's the same as y prime. df dx, it just means I have a function notation and they just wrote df dx. And then this means the derivative of that function with respect to x. When you get to multivariable cal, sometimes they even do like little dots for the first derivative, for the second derivative, or physics. It's all the same, it's just different notation. So most common is this, and they give you a little explanation of how you say it. How do you say it? Y prime, dy dx, or the derivative of y with respect to x, df dx, or the derivative of f with respect to x, d dx of f at x, or the derivative of f at x. Cool, right? Before you know it, you're going to be using this like no one's business. Super simple stuff. All right. We're done. Now we just got to practice. All right, you guys ready? All we're doing now is practicing. Let's see if we can do this. It says find f prime of x. So I'm going to write f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. That's my definition. Which is equal to limit as h approaches 0, square root of x plus h minus square root of x all over h. Oh, I'm stuck. Now what? What do I do? Multiply by what?
Square root of x plus h plus x.
Yeah, what is that called?
The
Conjugate. Multiply by the conjugate. So here we go. Square root of x plus h minus square root of x over h. And I'm going to multiply that by square root of x plus h plus square root of x over square root of x plus h plus square root of x. When you do that, you get, and I'll try to write small but big, limit as h approaches 0. Square root times square root is just going to be x plus h, minus square root times square root is going to be minus x. In the bottom, do not distribute. Square root of x plus h plus square root of x. So here's what I have. The x's zero out. Now that you zeroed out the x's, the h's cancel out. Do you guys see that? Yeah. And now you can do direct substitution. H is approaching 0, so now here's what I have. F prime of x is equal to limit as h approaches 0 of 1 over square root of x plus h plus square root of x. H is approaching 0, so you get 1 over square root of x plus square root of x, which is the same thing as 1 over 2 square root of x. So finally, the derivative of square root of x is nothing more than 1 over 2 square root of x. Yay or nay?
I know.
Now that happy face reminds me, you know how it's kind of crooked? I remember, I have a friend she's very blunt, and she came up to my face literally like right here, and then she's like, your face is crooked. And I'm like, thanks for telling me my flaws. She's like, this nostril is a little bigger than that nostril.
Everyone's face.
She's also kind of weird. But her face is not crooked like mine, according to her. Yeah, it's okay. I'm not hurt. All right, ready? Oh, what? She's not gonna watch this, and if she does, what's she gonna do? Beat me up? She's like a little stick. All right. Sorry, I shouldn't say that. Here we go. F prime of x equals limit as h approaches 0. Guys, for the record, I've never ever been in a fight. That's the truth. So she probably could beat me up because I've never been in a fight in my life. At least not like an actual physical fight. 1 over x plus h minus 1 over x all over h. All you're doing is simplifying this. So, common denominator. Multiply this one by x plus h over x plus h. Multiply this one by x over x. So here's what we have. We have limit as h approaches 0, and I'm going to have, in the top, I'm going to have x minus h. I distributed the x plus h, guys, with that negative there. All over x, parenthesis, x plus h, close it, put the h on the side. Do you guys like that? Or I actually saw a video that does times 1 over h. Maybe that's better? No? Okay. I was like, yeah, that might be better. There it is, h on the side. What cancels out first? The x's. Now that I've canceled out the x's, I can cancel out one of the h's. Remember, you still have a negative in the front. That's a -1 right there. So let me rewrite it. Limit as h approaches 0, -1 over x parenthesis x plus h. H is approaching 0, so this is just -1 over x squared. So f prime of x is just -1 over x squared. That's my derivative.
I actually like
Yeah.
one
What, the 1 over h on the side times 1 over h?
but I can do that.
Yeah, they Khan Academy was emphasizing times 1 over h to show that the h goes in the bottom. How people are like always like, how'd you get the h over there? Like key change flip, but I kind of liked it. All right, here we go. Ready for letter C? We're negative 1 over x squared. Here we go, guys. F prime of x is equal to limit as h approaches 0. 5 parenthesis x plus h close it squared minus 5x squared all over h. Yes. Equals. X times x. X squared. X times h is xh, but you're going to have how many of them? So 2xh. H times h is h squared. And I'll slow down. Yeah, we're about to distribute it. Yeah, that's fine. Let's see if it fits. Limit as h approaches 0. I'm going to distribute that 5 there. You'll catch up. I'll slow down right here. Let me just do this. Okay. What's going to zero out? What can I factor out? Limit as h approaches 0. Here's the h factored out. 10x plus 5h over h. What cancels out again? The h's. And h is approaching what? 0. So all you have is 10x. So f prime of x is nothing more than 10x. You could have, but there is no 5 that would have canceled out. So if I would have done, so don't write this down, just listen. If I would have factored out the 5, it would have looked like this, and the h. 5h, and that would have been 2x plus h over h. Look, the h's would have canceled out, and h is approaching 0, and you would have gotten 10x anyways, because it would have been 5 times 2x. Yeah, if I don't see anything that cancels out with the bottom, I don't factor it out. Like, I just factor out stuff that can cancel out. You know what I mean? All right, before we do letter D, remember what a derivative is. It's an instantaneous rate of change or a tangent slope. Look at letter D. It's a linear line. What do you think I'm going to get? I'm going to get a 7. Do we understand that? No? Okay. 7x plus 5? No, it's okay. It's okay. Look, 7. Don't write this down. Just listen. 7x plus 5 is a linear line like this. It's really steep. I'm just going to pretend it's that. If I told you, give me the tangent point at that, well, the tangent line is going to look like the same line. Does that make sense? No? Because if I have a curve like this and I tell you what's the tangent there, you're going to tell me that. And then whatever that slope is, that's my tangent slope. But if I have a linear line and I told you to give me my tangent line, the tangent line is going to be the same as my linear line. You know what I mean? Now, because it's the same, remember that tangent slope, like you need a tangent. Remember that derivative means instantaneous rate of change. This is always changing at a constant rate of change. It's always changing at a rate of 7. Does that make sense? So when I do my derivative, I'm just going to get 7. Now I know, let's just look at it, guys, to see how, just so we can get experience with it. Here we go. F prime of x equals limit as h approaches 0, 7 parenthesis x plus h, close it, plus 5 minus parentheses 7x plus 5, close it, all over h. I'll slow down. Yeah, I'm picking up the cues. Okay, I'll stop. Here we go. Distribute the 7. So limit as h approaches 0, 7x plus 7h plus 5 minus 7x minus 5 all over h. I'm going to zero out whatever zeroes out. 7x's, 0 out. Positive 5 and negative 5, 0 out. I have an h. It's 7h over h. Can I cancel out the h's? Look at that. What's the only thing you have left? 7. 7, go to heaven. And there it is. What do you guys think? Now we just keep on practicing, guys. That's all we're doing here. We're just practicing. What do you think we're going to get a number 1? 3. We better get a 3. Let's find out. We better limit as h approaches 0, 3 parenthesis x plus h minus 1 minus parenthesis 3x minus 1 all over h. Limit as h approaches 0. I'm going to distribute 3x plus 3h minus 1 minus 3x plus 1 all over h. The 3x zeroes out. The 1's zero out. Can I cancel out the h? And there it is. Again, you got f prime of x is equal to 3. What do you think, Gonzalez? All right, here we go. Next one, guys, and I'll try to slow down on this one. F prime of x is equal to limit as h approaches 0, parenthesis x plus h, close it, squared, minus 2 parenthesis x plus h, close it, plus 3, minus that whole function, x squared minus 2x plus 3, all over h. Before I continue, does everyone know where I'm getting this formula from? Okay. Valencia? Okay. Abdul Kareem? Okay. Here we go. Where'd it go? Let me see. I think I have enough space. I'm going to find out right now if I do or not. Limit as h approaches 0. Let's expand it. X times x is x squared. X times h is xh. We're going to have how many of them? So 2xh. H times h is h squared. And then I'm going to distribute that negative. Minus 2x minus 2h plus 3. And I'm going to distribute that negative. Minus x squared plus 2x minus 3. And all this is over h. Yeah, I have enough. The 3's zero out. The x squares zero out. The 2x's zero out. If they don't, something's wrong somewhere. What can I factor out? An h. I think it's worth it to do another line here limit as h approaches 0. You don't have to. You don't have to. You can just cancel out the h's, but I would because there's always errors here. 2x plus h minus 2 all over h. What's going to cancel now? The h's. And h is approaching what? No, yeah, h is approaching 0, so this derivative is 2x minus 2. So, in conclusion, f prime of x is equal to 2x minus 2. Good job, guys. All we're doing is practicing. Number 3. I don't think it's going to need that much space, so I don't know why I gave this one a lot of space. Here we go. F prime of x is equal to limit as h approaches 0 of 1 over parenthesis x plus h close it squared minus 1 over x squared all over h. Commons and I guess let's go ahead and expand it first. Equals limit as h approaches 0, 1 over x squared plus 2xh plus h squared minus 1 over x squared, and all that is still over h. Yeah, because eventually, I mean, I guess you don't have to expand the denominator, but when you multiply by the numerator, you eventually have to expand it so you can cancel stuff out. Multiply this by x plus h squared, or the x squared plus 2xh plus h squared over x squared plus 2xh plus h squared, and multiply the left one by x squared over x squared. Don't worry, we're almost done this. Limit h approaches 0, and here's what we have. X squared, and I'm going to distribute the negative, minus x squared minus 2xh minus h squared over, and in the bottom I'm not going to distribute, x squared parenthesis x squared plus 2xh plus h squared close h. I brought the h up. Yeah, I'm slowing. I slowed. Have I lost anyone? Alvarez, you okay? Let's cancel some stuff out. The x squares cancel out. Now I can factor out an h. So I'm going to write limit. No, I'm just going to factor out the h. As h approaches 0, here's my h. Negative 2x minus h all over in the bottom x squared plus 2xh plus h squared times h. Now the h's cancel. I'm slowing down, guys. I'm slowing down. Now the h's cancel. And h is approaching 0, and I can do direct substitution now. That's an x squared down there. So here's what you're going to get. Let's see, negative 2x on the top, and on the bottom that has an h and that has an h, so those are zeros. X squared times x squared is x to the 4th. Let's reduce this. I have 1x on the top and I have 4 x's on the bottom. Negative 2 over x cubed. There it is. Semicolon f prime of x equals negative 2 over x cubed. Yeah, that was a lot. Sorry, guys. What? Oh, you see how right here I have 1 and then right here I have 4? So I did laws of exponents. So I canceled this one with one of those, so it turned to a 3. The x, this x on the top, I canceled it. Yes, simplifying. You can, but usually you want to have a degree that's positive. But you can move it to the top. Negative 2x is negative 3. How do we feel, guys? Yeah, we're just trying to perfect our skill. Let's see. Yeah, all this is just perfecting. You think we'll finish today? Nope, no delta math. I think we can. All right, here we go. Nah. You guys ready? Here we go. It wants me to find the derivative 2 different ways. First, it wants me to try it this way. So let's try it that way. I'm going to write f prime of 2 is equal to limit as h approaches 0 of 1 over 2 plus h minus 1 over 2 all over h. Yes, sorry. Oh, did I mess up? Oh. Say it again. H? Yes, because it's an instantaneous rate of change. I want my delta x to approach 0. There's 2 alternates. Both of these mean the same thing. It's like saying, let me see if I can describe a visual. So it's like saying I have like, so here's x squared. I'm trying to do x squared. So I'm exaggerating y equals x squared. And think about this point 2 comma f of 2. So on one hand, I'm doing this, limit as h approaches 0, f of 2 plus h minus f of 2 all over h. So that is trying to find my instantaneous rate of change at 2. That's not the only way. You could also do, that is f prime of 2, right? You could also have done this. So let's see, f prime of 2, don't write this down, just listen. Limit as x approaches 2 of f of x minus f of 2 over x minus 2. So think of that as like I have another point over here, and we're going to call that x comma f of x. See? So right now, if I erase the word limit, that's just a secant slope like this, right? But notice as x approaches 2, that black line starts blending into that blue line as you make x approach 2. Does that kind of make sense? Yeah, so it's just 2 different alternate ways of getting your instantaneous rate of change. Yes. A is like my x-coordinate where I want to find my derivative. This one's telling me to find it already with immediately plugging in A. Both of them are kind of the same thing. Okay, check it out, guys. All I'm doing is using algebra. I'm going to multiply this one by 2 plus h over 2 plus h. Multiply this one by 2 over 2. F prime of 2 equals limit as h approaches 0. 2 over 2 parentheses 2 plus h minus 2 plus h over 2 parentheses 2 plus h all over h. Maybe I should have done it in one line. Sorry that I didn't. F prime of 2 equals limit as h approaches 0. 2 minus 2 minus h. I distribute it, put parentheses around it so you can see, distribute the negative. All over 2 parentheses 2 plus h, close it, put the h on top, like that. I'll bring it up, sorry. What's going to cancel out? Well, first zero out the 2's, and now cancel out the h's. H is approaching 0, so this is going to be a negative 1/4. Prime. F prime of 2. A is 2. Yeah, I guess so. Yeah, they're both right because A is 2. Does it make sense? Yeah. 1 over x looks like this. And right at 2, it's going to be a negative slope. Cool? Will we get the same answer if we use the alternate definition? You should, unless there's an error. So I'm going to use blue, or should I use green? Green? Okay, green. Here we go. I'm using the alternate definition. F prime of 2 equals limit as x approaches 2 of, what's the function? 1 over x? 1 over x minus 1/2 over x minus 2. I can't do direct substitution. Multiply this one by x over x. Multiply this one by 2 over 2. Here we go. F prime of 2 is equal to limit as x approaches 2. 2 over 2x minus x over 2x all over x minus 2. Now slow down. The denominators are the same, so limit as x approaches 2. 2 minus x over 2x, and I'm going to bring up the x minus 2, like so. I can't cancel out just yet, because I need the polarity of the numerator to be opposite. I need the x to be positive, and I need the 2 to be negative. So what can I factor out in the numerator? A negative 1. F prime of 2 equals limit as x approaches 2, negative factored out, x minus 2 over 2x, x minus 2. The x minus 2's cancel each other out. What is x approaching? 2. So what's 2 times 2? Negative 1/4. Did we get the same thing? Heck yeah, we did. How do we feel? Can we take some more? Should we take a little break? Okay. Any other questions, guys? Are you ready to rock? This one's kind of lame because it's a linear line. So it's going to be a 3 no matter what. Should we just skip it because it's lame? All right. Do it later. You guys can do it later. Look at question 6. Do you guys want to get a head start? See if you guys can do it. It's not 0. Did you say 0? Oh. Okay, don't look up until you feel the need to look up. Like you guys started. You know what I mean? If you got stuck, you can Did you at least do the first steps like this? You are winning. If you did the first steps like that, you are winning. Buy yourself an ice cream because you're winning. I used to have a favorite Dairy Queen. I would go there all the time. I can't go there anymore. Let me see. Where did I mess up? Oh yeah, you're right. You're right, man. I would have gotten it wrong. Thank you, miss. I would have gotten it wrong. So it has to be multiplied by the conjugate, and I didn't. But now it's right. What'd you say? Talking smack? Did you say you should teach? Yeah, here. Grab the marker.
I just said you had the sign wrong. I didn't know.
I did that on purpose, miss. No, I didn't do that on purpose.
He was like, I was just.
The 4's zero out. The h's cancel out now. Now I can make h approach 0. The square root of 4 is 2. And 2 plus 2 is... So this is 1/4. That's it. All right. I'm going to try the other one. I'm going to put that in black. So here we go. F prime 3 equals limit as x approaches 3 of square root of x plus 1 minus, say that again? Yes, I'll stop with the commentating. I'll stop commentating. Say it again. I think by the test we're taking a shortcut. So we will have a quiz before we show the shortcut. We have to, guys, because once we show you the shortcut, you're never gonna go back to this. It happens every year. It doesn't matter if I tell you, like, use the limit notation. You guys won't use it. You're like, oh, shortcut. Hi, tired? I'm sorry, miss. What do you think, Paracello? Where'd I get what? Did we get the same answer? Yes. We're almost done, guys. 7 is the last one, and then the rest is non-computational. We skipped 5? Oh, yeah. We skipped 5 because it was a linear line. Number 7. See if you guys want to see if you guys can do it on your own también? See? Mr. 305. Because both definitions come out all the time. You just got to recognize, because both definitions come out all the time on not only the AP exam, but in calculus in general. So if you can recognize that it's a derivative, you know what I mean? Like sometimes you're going to see a limit, and you're going to be like, oh, that limit's just a derivative. And then you just take the derivative. F prime of 1. I'm not going to do the commentating, guys. So I'm doing number 7. Whenever you feel like looking up, look up. The 5's 0 out for my YouTube fans. I'll do anything for my fans.
Yeah, he's talking to his man. No, I was like, you know, they're like, you know, like the villain trying to like, oh, it's Chavez.
There you go, fans.
Like that little first scene wrecking the church. Oh yeah. You're kidding. The stupid ungrateful lettuce broke. So think again, paper mate. Exactly. Did you get 2? What's the line called? I put like line 1. What is that line? The little like apostrophe. Oh, the part. You said tangent on there.
Okay. I tried to show every detail for my fans, for you guys. Yes. Which one? The one in red or the one in black? All right. So I started off with writing the expression f of a plus h, which is, see how I have x squared plus 4? So wherever you have an x is where you're going to type in your a, which in this case was 1, right? But it's not just any a, it's a plus h. So 1 plus h squared plus 4, which is that. See? Yeah. And then I just expanded. 1 times 1 is 1, and then 1 times h is 1h, but you're going to have 2 of those. And then h times h is h squared. And then I dropped the parentheses like it was hot, and I added it to number 4. See? 4 plus 1 was 5. And then this one, that 5 that you see by itself, that's just f of 1, right? 1 squared plus 4 is 5. How to get the 5 where? Oh, 1 plus 4, because I dropped the parentheses. I just added those. You can, and then 1 minus 1. You'll get the same answer. Okay. The other side, you might find it easier. Oh, which one? The black one? You want me to do some commentating? F of x is x squared plus 4. F of 1 is 5. Let me see.
Oh, I know what I did.
You know what you did? Oh, I heard we got a true computer science teacher.
Wait, did we actually?
I think so. Well, I shouldn't be saying it, so you gotta wait. No, like. Well, you'll see. I mean, she knows. She knows this one. All right. Yeah. Heck yeah. Heck yeah, we'll go back. Get you some math life. I can do this all day.
You do it all day.
Put me in an office, tell me to do research on aerodynamics of an airplane and to get you a new design for a new Boeing 747 for a new front airhead. We can do that. We're going to do it in this class.
Oh, yeah.
Yeah.
Is that going to be like a project that we do?
No, we're just going to, it's a 1-day deal.
No, it's an assignment. Become the Wright brothers in less than 24 hours.
Oh, that's a cute happy face. All right. Check it out, guys. This is how you're going to see it in UH. Look at this question. Look, everyone in the question 8. Look at question 8. Given f of x equals negative x squared plus x, which of the following expressions represents f prime of x? Take 30 seconds. See if you guys can do it on your own. Okay, a minute. Uh-oh, what happened?
I dropped it and
Yes, I'm not strong.
you are strong. Everyone's strong. You're strong. That's all that matters. Let him have like the slide.
I can't do it.
How many? Wait, why? I'm saying to you. LOL. Can you just like stop the What is it? What is it? It seems like she really wants to. Oh, never mind. Yeah.
Which one is it?
Wait.
Yeah.
What is the difference between?
Why is it not B, guys? Because it's missing the limit. Why is it not C?
Because we're approaching 0.
It's approaching. Perfect. It's approaching X. Go to number 9. Same deal. See if you guys can figure it out.
I got this one to the word to find it. The satisfaction Are you next? You called like I can't open it, but
What's the answer for number 9, guys?
I have
E. It can be B because look when it approaches. H approaches X, so it can be B. It's letter E as in Eric. Or Aaron. Your mom. I'm sorry, I'll stop. All right, number 10. Let's see if we can figure this one out, guys. Number 10. No.
a needle falls, it just breaks off in there, I'm done. Yeah. I think it's B.
You guys got it?
I think it's B. I just like looked at it like sounds like.
Well, both. I mean, I'm going to do it with you guys, but first I want you guys to give it a
Do you
shot.
have to do work for this?
No.
Okay.
This,
I was like, I did not put it on. Let me think about it. I think it's B.
seniors, what do you guys think it is? Which one? You said B? Let this give you a hint, guys. F of A plus H minus F of A. So it looks like it's obvious that A has to be -3. Notice there's a square on there. Is -3 squared 9? So it has to be B. Okay, look, if I were to tell you, let's go here on the side. If I were to tell you that f of x equals x squared, and I told you that I want my derivative at -3, I want f prime of -3, you guys would have told me f prime of -3 equals limit as h approaches 0 of parenthesis -3 plus h close it squared minus parenthesis -3 close it squared all over h, which is this right here. See, -3 squared is 9. Let me put this circle here. That's 9. See, isn't that the same thing? So that's why it's letter B, guys. We're going to do another practice. Look at number 11. Look at number 11. And we're going to need unit circle help. We're probably going to need to take quizzes on that pretty soon. But don't worry, we'll announce it. Well, you know what? There it is. There's the announcement. We'll start next class period, 5 minutes. The first 5 won't count.
Okay,
Yeah. So the first, I haven't even looked at it. Yes. What's the answer? All right. You didn't understand number 10? Okay. The question is this. This stands for something. It stands for the derivative of a function. They want to know what's the function, and they want to know what's the a value. That's what they want to know. This means f prime of x equals, really, literally, it means f prime of a. Limit as h approaches 0, f of a plus h minus f of a all over h. They want to know what is f of x and what is the a value. Does that make sense now? So the easiest part is your a value because of this. What is the a value? Pi over 3. Can you tell us how you got it, miss? minus f of a. Perfect. What is my function? Yeah, what is the function? Was it a cosine? Was it tan? Sine. Sine of what? No, just sine of x. So let's look for that. There it is. Well, I need to answer the seniors first real quick because I can tell they're confused. Okay, seniors, really fast. If I were to tell you, give me the first step in finding the derivative at pi over 3, and I were to tell you that the f of x is sine x, I would hope that you tell me before we even start, don't write anything down, just listen. You would say, well, the derivative is limit as h approaches 0 of f of x plus h minus f of x all over h. Yes or no? Okay, now I'm asking at pi over 3, so you're going to write, don't write this down, just listen for now. F of pi over 3 equals limit as h approaches 0, f of pi over 3 plus h minus f of pi over 3 all over h. Yes or no? So then you would go, remember, I'm telling you that f of x is sine x. So then you would go f of pi over 3 equals limit as h approaches 0 of sine of pi over 3 plus h minus sine of pi over 3 all over h. Do you guys agree? So far, you agree? Okay, it's okay if you don't. We just started today. We need more practice. This sine of pi over 3 is a number. On the unit circle, perfect. On the unit circle, pi over 3 is at 60 degrees. It's a y value. This is square root of 3 over 2. And that's what I have in that question. So limit as h approaches 0 of sine of pi over 3 plus h minus square root of 3 over 2 all over h. What was my function? Sine x. At what value did I want it at? Pi over 3. Does that make sense, guys? Okay, if you want to write down some notes or put some details on what we just did there. What was the question on the screen? She went with Montalongo, right? All right. Good question, miss. This is your function in the inside, and there's the squared. The negative 3 plus h was where your x was. X squared. See? F of x squared. Good question, Gonzalez. Keep asking them. That was a good one. Ask some more. We can take some more. We can take some more. I'll stop. That was. All right. I just got a headache from the spinning of the head. I think like the stuff inside just okay. Anyways. All right, number 12. Let's see how smart you guys are. Don't worry, we're almost done. It says finding the equation of the tangent line of f of x at x equals 2. What do I need for a tangent line? A point and a slope. Do I have a point and do I have a slope? Yes. Check it out. This is your point. The point is 2, 3. And let's check it out, guys. Look what it says. You see that little thingy there? That's called a prime. This is your slope at 2. Put that in there. This means tangent slope at x equals 2 is 5. That's what it means. Tangent slope at x equals 2 is 5. In words, you say it f prime of 2. Say it with me. F prime of 2. Okay. Yeah. What's a cow's favorite? Never mind. I don't know the joke. It's something to do with prime, obviously, right? Prime rib or something, but I don't even know what the first joke was. All right, here it is. I know. I don't know either, miss. All right. I don't know.
A moose nut. Bruh.
All right, here we go. Tangent line. It was funny. Y minus 3 equals slope x minus 2. Leave it alone, especially if you're prone to making errors. Yay or nay? Okay, look what the next equation says. Find an equation of the normal line of f of x at x equals 2. It's the same information. So I'm going to do the same thing except that my slope, what's my new slope? Perfect. Negative 1 over 5. Y minus 3 equals negative 1 over 5 x minus 2. Leave it alone. Yay or nay? All right. We just have a few. Relax. So we're kind of going into values that are not differentiable. We will tell you why right now in a little bit. You know what? I think you guys can figure it out on your own. Maybe. We'll see. Okay. Red? No, don't worry. I know we've done a lot, guys, but we're almost done. The graph of the function y equals f of x shown below is made up of line segments joined end to end. At what values of x between negative 4 and 6, between negative 4 and 6, is the function not differentiable? So what does that mean? Not differentiable means does not have a derivative. In layman's terms, it means does not have tangent slope. First bullet, second bullet. Between negative 4 and 6, there are 1, 2, 3 values, 3 x values. Take a guess. What do you think those x values are? One of them is where? Not at 1. Give me x values. X equals 2, 1, 2. Nope. I have a tangent slope at that moment.
I'm thinking when x equals x.
Okay.
Oh, wait.
Let's find slopes first. What's the slope of this first segment? It's just rise over run. So let's see. I go up 2 to the right 4. So that is the slope of a half. Does everyone know how I got that slope of a half really fast? Okay. Now, what is the slope of this segment going down? So let's see. It looks like I went down 4 to the right 1. So that has to be a slope of negative 4. Does everyone see how I got that? And then this slope here is a slope of 0 because it's just a horizontal line. And then this is a slope of, let's see, I went up 4 to the right 2. So that's a slope of 2. Yeah, all those, if I have slopes, I have tangent slopes. Where would I not have a tangent slope? No, there's no jumps, there's no holes. At the what? I know this is hard, guys, because you've never experienced this before. A change, okay, perfect. Guys, look, this whole line segment, the whole way, my slope is a half. So that means I have a tangent line between negative 4 and 0, no matter what. It would be that same line. Between 0 and 1, I have this other line in blue. And that's slope of negative 4.
Okay, so it would be
So right at x equals 0, you do not have a tangent line. Because there's two different values. One from the left is a half. The slope from the left is a half, and I'm approaching 0. And the slope from the right is negative 4. I'll give you an easier definition, and you'll never forget it. Can you have a tangent at that corner? No. How do you draw the tangent? Do you draw the green line? Do you draw the blue line? So here's the easiest definition. You cannot have tangent lines at corners. You can't. So if I have something like a nice curve, so look, just listen right now, guys. Don't write anything down. If I have a nice curve, everywhere through that curve, I have a tangent line. Tangent line, tangent line, tangent line. Do you guys see that? But if I have a corner, how do I decide how my tangent line looks? If I have a corner, what do I do in that corner, guys? I mean, do I draw my tangent like that? Do I draw my tangent line like this? Do you guys see the conundrum? So you cannot have tangent lines at what? Corners. So what are my corners that I cannot have a tangent line? At 0, give me the x-coordinates. 0, 1, 4. So there it is. So where are you not differentiable? Not differentiable. Differentiable at x equals 0, comma 1, comma 4. Don't worry about the endpoints negative 4 and 6. That's another story that we'll talk about later. What happened? Oh, I thought you had a question. Oh, I didn't hear you, miss. I'm sorry. Graph the function's derivative. We already have the slopes, guys. Look, you draw a scale. I'm gonna call this y prime and x. Between negative 4 and 0, what's my slope? 1/2. Is it always 1/2? So go to negative 4, make a circle, and go all the way to 0, make a circle at 0. And that's a 1/2. The y value 1/2. Yes. It's exactly like the velocity curve. Graph the function's derivative. Between 0 and 1, what's my slope? Negative 4. So go to negative 4. I'm going to say negative 4 is right there. Hole, solid, hole. Between 1 and 4, it is what? 0. So there it is, 0. And between 4 and 6, it is what? So here it is, 4 and 6. How do we feel? Dime. Latinos arriba, 305. Sorry, guys. I'm trying to do Mr. Worldwide here. Mr. 210. We good? All right. Last one, and this will be it. Sketch the graph of a continuous function f with f of 0 equals negative 1 and f prime equals 1 and negative 2 for x less than negative 1 and x greater than negative 1. Remember, this that I'm circling, those are just, starts with an S, second letter L. So those are just slopes. And it looks like they're just constant. So that means I have linear lines. Constant slopes. So f of x must be linear. Start with that coordinate. Don't worry. We're done, guys. Here's the last one. 0, negative 1. Point. 0, negative 1. Here is negative 1. That point, 0, negative 1, is it to the left or to the right of x equals negative 1? To the right. So I have to look at that negative 2. Do you guys see that? So from that point, I'm going to go, let's see, I'm going to go 2 to the right and 1 down. Wait, no, the other way around. 2 down and 1 right. I don't know why I did that, guys. 2 down, 1 right. Yeah. No. This is y, this is x. I'm not doing y prime and x. I'm graphing f of x. If it were a horizontal line, it would be a slope of 0. And I don't have a slope of 0. I have a slope of 1 and a slope of negative 2. Yes. All right, this goes forever like this, guys. Now I'm going to go 2 up and 1 to the left. So that point, make it a solid. I should be at negative 1 comma 1. There's the slope of negative 2. I'm going left to right. Now to the left of negative 1, it better be a positive slope, right? So here it is. Go down 1, left 1, point. You should have a point at negative 2, 0. And there it is. We're done. I know, guys, it's hard because we've never done this before. This, let me go ahead and label. This black line here has slope of 1. Let me go ahead and color code it. Blue. And this line here in green has slope of negative 2. Negative 2, 0. Because they have the slope of 1. Yay or nay? Okay. We're going to see if we can do this on our own, guys.